In this section, we're looking at mutually exclusive events, which just means that they can't both happen at the same time. So if one of them happens, we know that precludes the possibility that the other could occur. In the language of set theory, we would say that the events A and B are disjoint, so they mean the same thing. And another way to sort of write this out would be that the intersection of A and B is empty, and that the probability of A and B is 0 because they can't both happen at the same time. So in example 71, we are looking at the situation where 2 dice are rolled, and we're just going to take a look at each of these 3 events. And event A is the event that the sum is 7. Event B is that the sum is 10. And event C is the event that they both dice show the same number. So we're just going to check and see which of these pairs are mutually exclusive. So events A and B. And if I roll a pair of dice, event A is that the sum is 7, and event B that the sum is 10. These are mutually exclusive because if I roll a pair of dice, the sum can't be both 7 and 10 at the same time. A and C. So A, the event that the sum is 7, and event C that both dice show the same number. A and C are mutually exclusive here because if both dice did show the same number, that means that the sum would have to be even, right? And of course 7 is an odd number. So A and C are mutually exclusive. And events B and C, event B is that the sum is 10. Event C is that both dice show the same number. These are not mutually exclusive, and they're not because I can think of a particular outcome that would be in both of these events. So, for example, I think the only one that would satisfy both B and C would be getting double fives. So B and C are not mutually exclusive because the event double fives is in their intersection.